Students, in our previous lecture in which we have discussed the definition of equilibrium, we have seen that a body that is at rest, or if it is moving in a uniform motion, is in equilibrium if resultant of all the forces acting on it is zero. This was the definition of equilibrium, and we have discussed the example of book. We have discussed the example of a picture hanging on the wall. We have discussed uniform motion examples like aeroplane and paratrooper falling down from the sky. But we have seen that in all these examples, the objects, they are at equilibrium, but we have to go through different conditions. These objects which are at equilibrium, they have to go through different conditions. They must satisfy one of the two conditions if they are at equilibrium. So here we are going to discuss the different conditions for the equilibrium. It means that any object which we say that this object is at equilibrium, then that object must be showing one of the two conditions. It must possess one of the two conditions, or it must satisfy one of the two conditions. So here we are going to discuss the first condition for equilibrium. According to the first condition of equilibrium, a body is said to satisfy first condition for equilibrium if the resultant of all the forces acting on it is zero. Here we are talking about the resultant of all the forces acting on it is zero. Means to say that that on the object there is not one force acting, there are number of forces acting on it, and the result of all the forces, means we say that here is an object and one force is acting from this direction, one force is acting from this direction, one force is acting from this direction, and in this direction one is acting in this direction, other one is acting like this direction. So resultant of all the forces which are acting on the object, they all are zero, right? In the example of book, we had seen that there was one force acting on it. One was the weight of the book, while the other was the reaction of the table, right? But here we see that there are number of forces acting on the object, and the resultant of all these forces which are acting on the object, they are zero. So this object will be satisfying first condition of equilibrium, in which the object is having a number of forces acting on it, and the resultant of all the forces acting on it is zero. We can also elaborate this first condition of equilibrium with another example. Suppose we have a log of wood, and it is hanging with two ropes. Here we can see that this is rope 1, and it is having an upward force in the form of tension. We denote this force by F1, and it is an upward pull, right? And here is the second rope, and again this is also having upward direction, and it is also a pulling force in the form of tension, and we denote it with the force F2. And now these are the two ropes which are pulling, which are having tension in it, and this log of wood, it is having a weight which is acting downward, right? And this log of wood is in equilibrium. It is not falling down, it is not moving, right? It is in equilibrium. Here we can see that there are a number of forces which are acting on it, and these two forces are balanced by the weight of the log. So this, here we see in this example, we can clearly see that there is number of forces acting on the log, and one force which is acting downward, it is balancing or cancelling out these two forces. So here we see that if we denote these forces by, we say that there was F1 force, F2 force, F3 force acting on, and there was number of other forces acting on it, and here Fn represents the total number of forces acting on the object. The sum of the resultant of all these forces which are acting on that object, that must be equal to 0. Here the sum, we represent the sum by this sign which is called sigma, It is a Greek sign, Greek letter called sigma, and it is used for summation, means sum. The word I am using is summation, which represents the sum, means sum of all the forces acting on the object, it must be equal to 0. So the objects on which there are number of forces acting on the object, their sum must be equal to 0, then we say that that object is satisfying the first condition for equilibrium. As we are saying that the forces are acting on the object from all directions, so we can convert the forces into x and y components, means maybe some forces are acting along the x axis and some forces are acting along the y axis, so the forces must be converted into x and y components. So if we say that the forces which are acting along the x axis, then we can convert them into x axis components, and we represent them by f1x. Suppose this is the first force acting along the x component, and then f2x, then f3x plus and fnx, where n represents any number of forces which are acting along the x axis, so they must be equal to 0. All the forces which are acting along the x axis component, they must be equal to 0. Again we are using a summation sign. We say that sigma fx means all the forces, sum of all the forces which are acting along the x axis, that their resultant must be equal to 0. Same way the forces which are acting along the y component, we represent them by f1y, f2y, f3y, and then fny represents the final number of, or the total number of forces which are acting along the y axis. Their sum must be equal to 0. So here f1y, f2y, f3y represents the number of forces which are acting along the y component, and fn represents the total number of forces which are acting along the y component. Their sum must be equal to 0. We can write it as sigma fy is equal to 0. So we see here that all the forces which are acting along the x component, x axis, they must be equal to 0, and all the forces which are acting along the y axis, they must be equal to 0. So this is according to the first condition for equilibrium. So as we had discussed before, that the example of the book laying on the table or picture hanging on the wall, all these are at rest, and thus they represent or satisfy first condition for equilibrium. As the object is totally in rest, it is not moving, or it is totally stationary, it means all the forces, whether they are acting along the x axis or acting along the y axis, or their sum is equal to 0. So they are totally according to the first condition for equilibrium. They satisfy the first condition for equilibrium. And again we had seen the example of paratrooper coming down from the sky. It also represents it also satisfies the first condition of equilibrium, as it is coming down with constant velocity or terminal velocity. So as its speed is not changing, it is constant, it is coming down with constant velocity. So it means all the upward forces and all the downward forces, they are cancelling out each other's effect, and the resultant force acting on the paratrooper coming down from the sky is coming down with the constant or terminal velocity, and it is in accordance with the first condition for equilibrium.